Hello chemistry fans, and welcome back to Chemistry 1032 problem solving session here at the Academic Success Center on Broward College North Campus. I am your host, Dr. Russell Betts, and I'll be guiding you through this problem today. So let's just jump at it. What is the product of the following reaction? Ooh, wow, hey now, that's a big molecule. There's an unsaturated triacylglycerol, so it's probably an oil of some kind. And hydrogen, palladium, carbon. Whoa, wait a minute now, what's going on here? This is your standard hydrogenation reaction. Basically what's going to happen is we're going to add hydrogen to the double bond. So these questions, although they look hard, are actually extremely simple. Because whenever you see these conditions, whenever you see them, think double bond. Now, why am I saying that? Because that is what it reacts with. So if you have these conditions, think double bond and start looking for it. Now, when I say double bond, I mean carbon to carbon double bonds. That's the ones. Now, these ones, carbon to oxygen, they don't react. They don't even worry about this reaction. But it's the carbon-carbon bonds that do. Okay? So basically, what's going to happen, wherever you see a carbon-carbon double bond, remove the double bond and add two hydrogens. That's kind of weird. So say just for example, we take this double bond right here. So let's just draw it right there. Okay? And we're not going to worry about the rest of the molecule right now. So we have a double bond, we add hydrogen to it, and what happens? You just add two hydrogens to it, just like that. You go from an alkene to an alkane. And that's all that happens. You go from an alkene to an alkane. Okay? So, the hardest part of this question is redrawing the structure. That's the hardest part. So let's just start real quick. I know, it's a pain, but you got to do it. If I can do it, you can do it. 1, 2, 3, 4. 1, 2, 3, 4. Now I'm going to draw the carbons in here because I want you to see it. 1, 2, 3, 4. Carbon to carbon. And 1, 2, 3, 4, 5, 6, 7. Okay, and then we're just going to put in hydrogens. There you go. So the alkene right here, let's put a couple of dots here. This alkene is now this alkene right here. Alkane. So it goes from an alkene to an alkane. All right? Now I'm just going to do the middle one. Here and here. Now, you may be asking, where are the other hydrogens? And they're there, but they were always there. If you want, you can draw them in. They were there to begin with, so they're still there. They're still there. The red hydrogens are the ones we're adding, okay? So if you want to just draw them in for completeness sake, feel free, go ahead. But the red ones are the ones we added. The black ones were already there. They were there in the beginning, okay? We're not adding the black ones. The black ones were present before the reaction. Okay? And let's just put the hydrogens in there. Again, remember, the black hydrogens were there to begin with. The red ones are the ones that are adding. Now, you have seen and you have dealt with the product of this reaction before. Here, this is an oil, more than likely, because it has an unsaturation or has an alkene. Okay? So this is probably some kind of oil, vegetable oil, let's say, for example. You hydrogenate it and you get a solid. Saturated. It's a saturated fat, so it's a solid. So if you ever read the container of margarine, for example, you will read the words partially hydrogenated vegetable oil. So they've taken an oil and they've made it into a spreadable solid, or a semi-solid, if you will. Peanut butter. Natural peanut butter has oil on top. There's always a layer of oil. Unnatural peanut butter spread, doesn't have that because it's partially hydrogenated. So they remove some of these double bonds to make it more solid in character. Okay, so you've seen this before and you've dealt with it before, but now you know what it means. All right. Now I know this is a lot. I know there's a lot of stuff here. I hope that it was clear, and I hope that you can do it yourself. If not, just raise your hand, get help from a tutor, come and see me in my office hours. Don't sit back on this. Don't think it won't be on your exam, because it probably will. It's an important reaction, and I want you to know it. Okay? So with that, I wish you good luck and good chemistry.